Alright, today we're going to go over page 61 and 62, 1 to 25 all, and 26 to 42 all. So I think I should be able to fit both parts into one video. And this is from the board up on the front. So it has the area of a square, which is the side length squared. A rectangle is length times width. The triangle is 1/2 base times height. Remember, the height is always perpendicular segment to the base, so you got to find something that's making a right angle with the base. Circle, area is equal to pi r squared. Use the pi button in your calculator. Perimeter or circumference, remember that's perimeter is if it's a polygon, circumference if it's a circle. So perimeter for a square, 4 times the side length, or you just add all the sides together. Rectangle, you just add all the sides together, it's 2 times the length times 2 times the width. Perimeter triangle is you just add the sides together. And for a circle, it's 2 times pi times the radius, or it's pi times the diameter. It's because, remember, 2 times the radius is equal to the diameter. The other thing you're going to need for this section is Pythagorean theorem. So if it says that's only for a right triangle, it says if you have a squared plus b squared, it's equal to c squared, and you square both sides, to find c, so c is actually the square root of a squared plus b squared, and Pythagorean theorem is used on a coordinate grid to use the distance formula, which we'll use a little bit too. So we're going to go through this homework now. Alright, so number 1, name each polygon by its number of sides, then classify it as convex, concave, and regular or irregular. So remember, polygon, we go by number of sides. So 1, 2, 3. So number 1 has 1, 2, 3, 4, and 5. So that makes it a pentagon. It is concave because it looks like it's caving in on itself. So right here, remember, if I made a dotted line, if I extended this side right here, it would go inside, but it makes it concave. And remember, if it's concave, it's automatically irregular. So the only way you can have a regular shape is to be convex. All right? And that's it for number 1. Number 2, we count the sides. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a nonagon. I counted those sides right. It is convex because if I extend all these sides, they all extend outside the shape itself. So that makes it convex. And since it's all the angles are congruent and all the sides are congruent, we're going to call it a regular. Right? And that's it for number 2. 3, stop sign. It's an octagon. And it's regular because all the angles are congruent. We're going to call this a quadrilateral. And we're going to say that's regular as well. I think it's slow-moving vehicle. It depends on if you count the triangle on the inside or the actual polygon. So we're actually going to count the polygon. There's 1, 2, 3, 4, 5, 6. So it's a hexagon. And because those little sides are shorter, it's irregular. So that's it for 1 through 5. Alright, number 11, find the perimeter and circumference and area of each figure. So, 6, it is a square, so the circumference, or the perimeter, is equal to 4 times the side length. So the perimeter is equal to 4 times 11. So the perimeter is equal to 44 feet. Don't forget your label. Now the area is equal to the side length squared. So the area is equal to 11 squared. If you don't know, that means it's 11 times 11. So area is equal to 121. And don't forget your square feet. Even though it looks like feet squared, it's actually supposed to be set as square feet. And that's it for number 6. Alright, 7, it's a circle. So remember, once again, the diameter is twice as long as the radius, so I know that the radius is going to be 6.4 centimeters. So I already know that's r. So my circumference is equal to 2 times pi times 6.4. So the circumference is about 40.2. 40.2 centimeters. So don't forget your centimeters. Now your area, that's going to be equal to pi times 6.4 squared. So I have to put 6.4 squared first, then put times by pi. So I type that in, I get my area is equal to 128.7. And don't forget your label, square centimeters. So guys, make sure you have your label for that one, your label for that one, and they're different. Okay? That's it. Alright, number 8, pretty easy. So because this, I'm going to call this the base right here. So I'm going to say this is the base. So think about it, guys. If I were to rotate this, it might be a little bit easier to see the base this way. So the base is always, whatever you want the base to be, that's fine. The height is always perpendicular to the base. So I see this right angle right here. That tells me that this is going to be the height. So when I find my area, it's equal to 1/2 times your base, which is 8, times your height, which is 15. And you just do 8 times 15, which is 120, and half of that. So my area is going to be equal to 60. And it's area, so it's square meters. Now perimeter is pretty easy. So perimeter, you're just going to add the sides together. So you're just going to do 17 plus 15 plus 8. So my perimeter is going to be equal to 40 meters. Remember, perimeter you can measure with a ruler. That's why there's not square meters. You're just measuring it. So that's like a distance. Area is like how many little boxes I can fit in there. That's why it's square meters. It's little squares I can fit in there. Alright, Vanessa's making a banner for the game. She has 20 square feet of fabric. What shape will use the most or all of the fabric? Alright, so as you see this word square feet, that tells us we're going to be using area. Okay, so a square with side length, I'm going to use area is equal to side squared. So my area is equal to 4 squared. So my area for the part A is going to be equal to 16 square feet. B, a rectangle with length, and if you're not sure, guys, draw a picture. A length of 4 and a width of 3.5. So I do area is equal to 4 times 3.5. 4 times 3 is 12. Half of that, half of 4 is 2. So 12. 4 times 3.5 is actually going to be 14 square feet. So I already know I can get rid of B, because 16 is bigger than 14. So C, I'm going to be using the radius of 2.5. So I'm going to say my area is equal to pi times 2.5 squared. I'm just going to type that into a calculator. And I get it's about 19.6 square feet. That's pretty close to 20. Now a triangle has legs of 5 and 5. It doesn't say anything about the perimeter, so I don't care about this one. I'm going to go 1/2 5 times 5. Half of 25 is 12.5. So I know that C is going to be my answer. That's it. So for number 10, I'm going to put these points on there. I'm going to point -1, 2, 3, 6, and 3, -2. So A is -1, 2. The left one up to 2. And I'll put an A right there. B is 3, 6. So I go right 3 up to 6. And then C is 3, -2. Alright, so I want to find perimeter and area. Well, the area is actually the easiest part, because area is 1/2 base times height. I'm going to call this the base because I know for sure that's a right angle right here. And I can also count this. So this is 1, 2, 3, 4, 5, 6, 7. This is 8 units. And the good news is I can count the height. So the height is from A to the base. So the little dotted line going from A all the way to that base, it's 4 units long. All right? So that's my height. So my area is actually going to be 1/2 8 times 4. 8 times 4 is 32. Half of that is 16. So it's 16 square units. So you can put units square. You can write out square units. That's our area. Now the perimeter is a little bit harder because you have to use the distance formula. So I'm going to use the distance formula here for A and C and A and B because I don't know how far they are. So A, remember, is -1, 2, and C is 2, 3, -2, positive 3, -2, and B is 3, 6. Now, I'm going to do the length of A, AB. So I'm going to use the x's for A and B. So I'm going to do -1 minus 3 squared plus 2 minus 6 squared. So remember, you have to do inside the parentheses first. So I get -1 minus 3 is -4 squared. 2 minus 6 is also -4 squared. Remember, when you square something inside a square negative, it's actually going to be positive, so it's 16 plus 16. So the length of AB is equal to the square root of 32. And I just have to make a... So we're going to say AB is about 5.7 units. So AB is 5.7. Now I'm going to do the same exact thing for AC. So I'm going to use A, and this time I'm going to use C. So I do the square root. I'm going to do -1 for A minus the x from C, so that's 3 squared. Now it's going to be plus 2 is the y from A minus -2. Remember, it's squared. So once again, I'm going to get the same exact thing. I'm going to get -4 in parentheses squared. Being in parentheses is important. And then minus a negative is plus, so I'm going to get plus positive 4 squared. So I get the square root of 32 again. That means AC is going to also be equal to about 5.7. And then finally, I know that BC is equal to 8. So my perimeter is going to be 5.7 plus 5.7, which is 11.4 plus 8. So my perimeter is going to be equal to 19.4 units. There's my perimeter, there's my area. Alright, name each polygon by its number of sides and classify it as convex and concave or regular. So just like the first couple problems. Right now we got a triangle. It is convex because if I were to extend any of these sides, none of the extensions would go inside the shape. So that's why it's convex. All the angles are the same, all the sides are the same length, so that means it's going to be regular. 12 is going to be, I'm going to count the sides, so I'm going to have 1, 2, 3, 4, 5, 6, 7. 7 sides, that's going to make it a septagon. Maybe it's heptagon, I think it might be a heptagon. It is concave because look, it kind of looks like that one side caves in, and if I extended those sides right here, if I extended these sides, the dots go inside, so it's concave, and every time you write concave, it's immediately irregular. You can never have a regular shape that is concave. So like 13, although it has all the angles are the same, all the sides are the same length, immediately I know it's concave, and which means it's irregular. Now it's 1, 2. I counted eight sides, so it is an octagon, but it is irregular because it's concave. $14 is a quadrilateral. It is convex because if I extend these lines, none of the dots go inside. But it is irregular because we do not know if it is, we do not know if all the sides are congruent, and the angles are not congruent, so it's regular. 15, once again, convex automatically, which are, I mean, not convex, concave, because, like I said, if I extended those sides right there, they would go inside the shape, which makes it concave, which automatically makes it irregular, and it has I think I counted 11, so I call that an 11gon. 16, it is a pentagon. It is convex because none of those sides would extend inside the shape. And it is regular because all the angles and all the side lengths are congruent. Alright, we're back to perimeter and perimeter, circumference, and area. 17 is a perimeter. Remember, it's a rectangle, so that's congruent. That's congruent. The opposite side lengths are congruent. So my perimeter is really easy. You do 2.8 plus 2.8, which is 5.6, plus 1.1, which is 6.7, plus another 1.1. So the perimeter is 7.8 meters. Now the area is going to be equal to 2.8 times 1.1, because it's length times width. So my area is equal to 3.08 square meters. Don't forget your label. Alright, look, there's at least one step of work. 18 is a circle with the diameter is 8 inches. That makes this radius right here going to be 4 inches. So my circumference is equal to 2 times pi times 4, which is 8 pi. Or you do 8 times pi in your calculator, and you get circumference is equal to 25.1 inches. Area is equal to pi times 4 squared. So your area is going to be equal to 16 pi. Or your area is going to be equal to, you just do that in your calculator. Area is going to be equal to 50.3 square inches. All right, that's it for 17 and 18. 19, pretty easy. It's a square. So my perimeter is going to be 4 times 6.5. So my perimeter is going to be equal to 26 inches. My area is going to be equal to 6.5 squared. So my area is going to be equal to 42.25 square inches. So there's my area, there's my perimeter. Alright, 20. Now guys, this is not part of the triangle. This is the height. And the height can be outside of the triangle itself, because the height has to be from a vertex all the way perpendicular. So the only way to go perpendicular would be go outside the triangle. It has to be perpendicular to the base. So the base is still 5 feet, so that's still a base, but our height is actually 8 feet. So my area is going to be equal to 1/2 times our base, which is 5, times our height, which is 8. 5 times 8 is 40, so half of that is 20, so my area is 20 square feet. Now the perimeter, you're going to use the actual length. So you're going to do, your perimeter is going to be equal to 12 plus 16 plus 5. So my perimeter is going to be equal to 43 feet. And I don't know, I'm being crazy, it's actually 33 feet. 12 plus 16 is 28, so my perimeter is going to be equal to 33 feet. And that's it for 20. So I don't have to find another height, because 6.5 is the height because it's perpendicular to the base 4.5. Now you do have to find this piece right there. So you're going to say that's A, and that's B, and you need to find C. So you say 6.5 squared plus 4.5 squared equals C squared. So I have to do 6.5 squared plus 4.5 and square it. So 6.5 squared is 40. 6.5 squared is 42.25, and then 4.5 is 20.25. So my C squared is actually equal to 62.5. Now to figure out actually what C is, you have to square root both sides. And I get C is about 7.9 centimeters. Alright, so I have C is equal to 7.9 centimeters. So to find the perimeter, you're going to have to add them all up. 6.5 plus 4.5 is 11, plus 7.9. So my perimeter is going to be equal to all three of them together, which is going to be 18.9 centimeters. My area is just going to be equal to 1/2 So back, we know this is equal to 7.9, so my perimeter is going to be all three of them. So my perimeter is going to be equal to 18.9 centimeters. My area is going to be equal to 1/2 times 4.5 as the base times 6.5 as the height. And I get my area is 14.625 square centimeters. So don't forget your labels. Alright, 22. I have radius is 5.8, so my circumference is equal to 2 times pi times 5.8. I just do that in my calculator. And I get my circumference is equal to 36.4 centimeters. Now I'm going to use my area. It is going to be pi times 5.8 squared. And just type that in your calculator. Make sure you do 5.8 squared first. And I get my area is equal to about 105.7 square centimeters. And that's it for 22. Alright, 22. Joy has a square that is 4 inches on each side. So she's got a square. It's 4 inches on each side. The picture is framed with the length of the ribbon. So she wants to use the frame would be the outside. So we're going to be talking about perimeter. So I know the perimeter of my square is going to be 16 inches. She wants to use that same frame, that same ribbon, to frame a circular picture. So that means I know my circumference has to be equal to 16 inches. That's what I want. So what I have to do is I want 16 to equal 2 times pi times r. So the maximum radius you can have is going to be if I get r by itself. So I just divide by 2 pi on both sides, and r will be all by itself. So I say r is equal to 16 over 2 pi, and I just throw it in my calculator. And we get the biggest our radius could be is about 2.5 inches. And that's it. Mr. Jackson has a circular garden with a diameter of 10 feet. Surrounded by edging. Using the same length of edging, he's going to create a square garden. What is the maximum side length of the square? So he knows that his circumference is equal to pi times the diameter. And he knows that, I don't want that. Our circumference, actually we do want that. So our circumference is equal to pi times 10 for the diameter. So my circumference is going to be about 10 pi, or about 31.41 feet. Now he wants to make a square that has the same edging. So that's another thing. So now we want the perimeter to also be 31.41. Now luckily with the square, we know that the perimeter is equal to 4 times the side length. So if I know that my perimeter is going to be 31.41, I can say it's equal to 4 times s. I divide 4 by both sides, and the side length of my square has to be 7.85 feet. And that's it for 24. So 25 is going to end part 1. So 25, you're going to have D, E, and F. and you're going to plot that. So D is -2, -2, so I'm going to go left 2, down 2. E is -2, 3, so I go to left 2 up to 3. And F is going to be 2, -1. So there's my triangle. Very similar to what we did before. So I know that this, I'm going to call this the base, because I can count this without doing any work. 1, 2, 3, 4, 5. So I know this is 5. I'm going to call it my base, because I can make a point perpendicular from there. And that is going to be at my height is going to be 4. So my area is equal to 1/2 base, which is 5, and my height, which is 4. 5 times 4 is 20, so my area is going to be equal to 10, we'll say, square units. You can either write out square units or just put units squared. So that's my area. Now perimeter, I have to find the distance between, I have to find EF and I have to find DF. So remember, I'm going to be using my points. So I have for E and F, I'm going to use my points for E, which are -2, 3, and F is going to be 2, -1. So remember, I put the x's together and the y's together. Underneath the radical, I'm going to do -2 minus 2 squared plus 3 minus -1 squared. So I'm going to get the square root of -2 minus 2 is -4 squared plus 3 minus -1 is a positive, so it's 4 squared. So once again, I get the square root of 32, which hopefully we remember from earlier. So we know the EF is going to be about 5.7 units. So now I'm going to do FD, or DF. I'm going to do my radical. I'm going to do -2, -2. So I'm going to do -2 minus 2 squared plus -2 minus -1 squared. Inside the radical, I get the first set parentheses turns into -4, then it's going to be squared. -2 minus -1, it's like -2 adding 1, so it's -1 squared. So I'm going to have the square root of 17. And I get about, DF is about 4.1 units. So if I know I know ED is 5 and 5.7 and 4.1, so my perimeter is going to be equal to 10.7 plus 4.1 is 14.8 units. That's my perimeter. And that's it for part 1. So this is only part 1. Look for mistakes, because those will be the accuracy problems later.